Magandang araw para sa magandang buhay bukas. I am JM Carlo Tiabaw and we are the Group 2. So we are done discussing the sampling distributions and point estimation of parameters. So now, we will proceed to the statistical intervals for a single variable. So, statistical intervals are essential for assessing uncertainty and accuracy in data analysis. They allow us to estimate unknown values, make predictions, and draw meaningful conclusions. So, it is very useful for our research. So, in this report, we will explore the different types of statistical intervals commonly used, their interpretation, and their application. This presentation will explore the confidence intervals and prediction intervals, their mathematical foundations, and practical significance in statistical inference.
Types of intervals. There are three types of intervals: confidence, tolerance interval, and prediction interval. So first is confidence. It is an interval estimate for a population parameter is called a confidence interval. Second is tolerance interval, a statistical measure that defines a range within which a specified proportion of a population is expected to fall with a given level of confidence. The last one is prediction interval, provides a bounds on one or more future observations from the population. These are the application of statistical intervals in various fields, including market research, estimating the mean income or customer satisfaction levels in a target population, quality control, assessing the proportion of defective items in manufacturing process, epidemiology, determining the prevalence of a disease in a population, finance, estimating the range of potential investment returns or portfolio value.
What really is a confidence interval? So basically, the world of statistics is just estimates. So basically, if we have a population of 1,000 apples, it is very impractical to measure all the parameters of those populations. So basically, what we do is we take a sample of, let's say, 100 apples to predict the parameters of the population. So basically, we cannot measure all of the apples. So basically, we're just going to measure what we can measure. And we are going to get sample parameters to predict the population parameters. So by using statistical tools or analysis, let's say the 100 apples has a mean of, say 143 grams. So this mean is not equal to the population mean. Basically, common sense, diba? Let's say, kung mag-measure naman tag 100 apples from a different sample, so basically, ang mean ana is 148 or mean 1, ano siya, is 2 is 150. So basically, hindi sila pareha. So basically, ang gagawin natin is ang tawag nito ay ang confidence interval. So, lahat dapat na mga parameters natin is naka-express na confidence interval. So, basically, ang confidence interval, instead na one value, ang confidence interval is a range of a value. So, let's say 148 to 150. So, tapos, meron tayo nakalagay na we are 95% confident that the real mean is within this range. Basically, that's all. So basically, you already know what is a confidence interval. So, what affects the width of a confidence interval? So basically, a confidence interval, a 90% confidence interval is like this. A 95%, it's much longer. A 99.9%, it's much longer. So our value ranges from here to here. So basically, what factors ang nagapadako sa iyang width or nagapagamay? So basically, there are two factors. Basically, ang variation. Variation, let's say, natay data up, natay apple na 100, natay isa ka apple na 200, natay isa ka apple na 150. So, basically, dako kayo ang variation. 100, 200, and 150. So, basically, dire. Let's say, natay 500. So, basically, ang atong confidence interval is wala ko ba eh. Sa example. Okay. Kaya mag-cut na naman ito, no? Okay. Basically, a sample or a population with low variation will lead to an accurate and more precise intervals. A small confidence interval. So basically, let's say kung ang data nimo gamay ra ang variation, ana, tapos basically mas accurate siya kumpara sa malayo ang variation. Hindi siya mas accurate. So, dayon, let's say kung ang other factor is the number of sample. So, the greater the sample, the more accurate we can get, the more precise we can get. So basically, kung sa lugar ang meaning ano, let's say, natay 1,000 apples. 1,000 apples na ang atong sample size is 999. Basically, ang mean ani is very close. Is approximately na kay isa ra ka apple ang kulang. So basically, kung gadaghan ang atong sample size, mas mag-accurate ang aton confidence interval.
We all know that confidence interval is an estimation to the population mean. So I will discuss it more further for you to understand to the whiteboard. So no further ado, let's go. So this means that our population mean or mu lies on the range of our lower bound and our upper bound. When we talk about estimate, we will put a hot notation so that we will know that the variable is an estimation. So, but nga nato nig kwan hot dire. Kana. So, this L means that the estimation of the lower bound. And this U is the estimate of the upper bound. And this is the interval form or the population mean. So, ang atong buhaton kay kwaon na to ang sample items and then kanang kwaon na to ang sample mean, which is the mu. Which is the sample mean. After ana, gamito na to ang sample mean to para kwaon ang value sa atong estimation sa lower bound and sa atong upper bound. And then, we will be using the probability of 1 minus alpha that the sample for which the two-sided confidence interval or CI will contain the true value or will capture the true value of our population mean.
X bar is the sample mean of a random sample size n from a normal population with known population variance. The two-sided confidence interval is given by P. The probability of P is the mean is between the lower bound and the upper bound, which equals to 1 minus alpha.
So we will talk about the normal distribution. So we are all familiar to the normal distribution and it is related to the statistical interval. So which is the ZA or the Z alpha is the value of the Z on the x-axis. So i-draw na po dire ang the normal distribution of the probability density function. So, which is the ring side is the negative infinity and dito ang positive infinity. So, the ring area is called EZ alpha. And the kaning area padulong sa infinity is known as the alpha. Alpha ni siya. And so that kaning area kay alpha, this area will be the 1 minus alpha. And so kani area above it under the z of the probability density function is alpha. And next, in our z over z sub alpha over 2, so the area above it under the z of probability density function, which is this kay diri gyapon, and then mao ni siya ang z alpha over 2. And ang area ani padulong sa infinity is also known as the alpha over 2. And it means that kani nga area, pag kani ang alpha over 2, so kani ay ang 1 minus alpha over 2. For example, z of 0.01 is the value of z-axis such that the area above the value is 0.01. So, to plot this is the area above is 0.01, and we find the z of 0.01. So, to solve the z.01 is we use the inverse norm function, which is given the area below and mean and standard deviation. To solve the z of 0.01 is given from the area below is 1 minus 0.01, and the mean is, we all know that the mean of standard normal variable is 0 and the standard deviation is 1. And when we plug into the calculator, we get the result of 2.3263. So the value of z.01 is 2.3263. Next example is find the value of z of 0.5, which is given the graph. This is 0.5. So we will know the area below is 0.95. This is 1 minus 0.5. 0.95. So by using this formula, the inverse norm, this is the area below is 0.95, and the mean is 0, and the standard deviation is 1, and when it plug this into calculator, the result is 1.6449. So therefore, this is the value of z.05. Next is find the value of 0.5 over 2. So the area below is 0.5 divided 2 is equals to 0.025. So we get the area below is, this is 1 minus 0.025 equals to 9.75. So by using this formula, the inverse norm,
The area below is the 9.75, 0.975, and the mean is 0, and the standard deviation is 1. And we plug into the calculator, the result is 1.96. 1.96. Therefore, the z of z point 0.5 over 2 is equals to 1.96.
Okay, so for example, here we have 5 measurements of impact energy, which is unit of joule on specimens of A238 steel cut at 60 degrees Celsius are as follows, given by 64.1, 64.7, 64.5, 64.6, and 64.5. Next will be the impact energy is normally distributed with standard deviation equals to 1 joules, and here the problem requires to find a 95% two-sided CL for the mean, the population mean impact energy. Here we have the probability of mean greater than or equals to lower estimate bound, and mean is less than or equals to upper estimate bound, and which is equals to 1 minus A. So given by 95%, here we plug in na to ang 95%, which is itong i-divide sa 100, equals to 95. So if you calculate the value of A, ito na yung i-manipulate ang kanina equation dire. So the result will be 0.05. So since nakuha na ito ang value sa A, we'll proceed to calculate the value of Z, which is A over alpha over 2. So it will result to 0.025. And if we subtract 1 to it, ang result ay 0.976 and 975. So ato na siyang pangitaon sa Z table o Z scores na value, which is ang kanang value na tulong na siya sa 1.96, which is ato ang Z value. So this X bar, since atong problem kay given kay 5 samples, ato na siyang i-add and divide by 5. So 64.1 plus 64.7 plus 64.5 plus 64.6 plus 64.5 and divide by 5, which will result to 64.48 joules. And here sa problem given na po datong standard deviation, which is equals to 1 joules. Ito na i-plug in. And n ang n mo na siya ang kanang given sa pila ka sample nga given sa problem, so which is 5. So next would be itong i-calculate ang lower estimate o upper estimate nga bound. Since nakuha na nato ang mga value, ato na siyang i-plug in sa formula. Since given na nakuha na nato ang mga value, ato na siyang i-plug in sa formula. So z bar is equals to 64.48 joules, and minus ang Z value is 1.96, and multiply natin siya sa standard deviation which is 1, and divide sa square root of n, which is 5. So the result would be 63.603 joules. If ito yung plug in sa calculator. So muna ito ang lower estimate bound. Next, itong isolve ang upper estimate bound. Okay, so sa lower estimate, ang value dahil kay 63.603. So, ito yung islan. 63.603. And let's proceed to the value of upper estimate, which is same lang yan po ng formula, but ang sign kay positive. So X bar is equals to 64.48 joules, and plus the value of Z, which is 1.96, multiplied by standard deviation, which is 1, and divide by the n or square root of n, which is 5. So if ato ni plug in sa calculator, ang value kay 65.357 joules. 57 joules. So muna itong value sa upper and lower estimate. And so based on the sample data, the probability that the interval 63.603 joules and 65.357 joules contains the population mean is 0.95. So we'll proceed to the sample size for specified error. If x bar is used as an estimate of mu, we are 100 times 1 minus alpha percent confident that the error E will not exceed as a specified amount E or error when the sample size is this n equation. So the equation for sample size is n equals to z alpha over 2 times standard deviation divided by E or error and raised to 2. So, dili nga problem kay mag-based lang ta sa previous example or problem which is alpha is equals to 0.05 and z is equals to 1.96 and standard deviation is equals to 1 joules and a over 2 is equals to 0.025 and ang e for this problem is given. So, ang e is equals to 0.50 joules. So, ang atong pag-solve sa sample size kaya ito lang i-plug in ang atong mga value. So, which is n times z 1.96 times 1 over the error which is 0.5 joules and it is ato siyang raised to 2. So ang result would be ang result ay kay 15.4 but we should reconsider that atong gisolve kay sample size which is ang dapat ang atong answer dili kay whole number. So ato na siyang i-round off kanang considering for ang iyang value, ato na siyang i-round off or round up, which is ang atong sample size nga makuha kay equals to n equals to 16.
Now we have done discussing the confidence interval of the population mean using the population variance with known. Now we learned how to solve if the population variance is unknown using the t distribution. Now the t distribution is a random sample of size n from a normal distribution with both mu and standard deviation are unknown. Now instead of the sample standard deviation, we will use s as this sample standard deviation in the random variable. In the t distribution, it is similar to the z distribution. Now, instead of using z, we will use big letter T is equals to x bar minus mu all over. Instead of we use lambda, we will use the sample divided by the square root of n. Now the t distribution is look like this. Now we know that the area of any PDF function is equals to 1 in any area of the PDF, and the estimate value of t is 0. To know that the commonality of the z, we will check that its shape is a bell curve and the estimate value of the t is equals to 0 and the range is from negative infinity to positive infinity. T is a random variable that we use to analyze the mu when the standard variance, hence the standard deviation, is unknown. Now we know that the sample standard deviation is S. And to get the S, we will use the formula of the standard variance of the sample from the sample standard deviation, which is S squared is equals to the summation from 1 to n of x sub I minus x bar squared all of the summation all over of n minus 1 to get the sample standard deviation.
all you need to do is square root the value of s squared. Now the estimated value of t uh, now the estimated value of t random sum now the estimated value of t random variable. Now the estimated value of t random variable, we know that is t. Now to get the t random variable, we will use this equation. T is equals to x bar minus mu all over the sample standard deviation divided to the value of your n. Now, fun fact to know about the t distribution is that degree of freedom as approaches to normal from 1, 5, 10, 30 to normal, it becomes that the t will be equal to z substitution. Now, to get the t, we should know that the alpha and the alpha over 2 is the area above the now to get now t sub alpha n minus 1 and t sub alpha over 2 n minus 1 are values of t, with n minus 1 is the degree of freedom on the t-axis, such that the area above the t such that the area above the such that t sub alpha n minus 1 and t sub alpha over 2 n minus 1 are the values of t, where the n minus 1 is considered to be the degree of freedom in the t-axis, such that the area above the under the t pdf t sub alpha n minus 1 t sub alpha n minus 1 and t sub alpha over 2 n minus 1 is the value of t, where n minus 1 is the degree of freedom on the t-axis, such that the area above under the t pdf is equal to a and a alpha over 2. T sub alpha n minus 1 and t sub alpha over 2 n minus 1 is the value of t, with n minus 1 is the degree of freedom. Muna siyang degree of freedom on the t-axis, such that the area above the under the t pdf is equal to alpha and alpha over 2. For example, we have t, that the area above of t is 0.05 and the degree of freedom is 7. Now, ang ato dong pangitaon dere, what is the area under the 0.05? Kung tanaw na to sa bell curve, muna siya, the estimated value of t is 0 from negative infinity to positive infinity. T. So, ang pinapasabot doon ng kuan, na daw dire, ang area daw padulong dito is 0.05. Na ang ato ng pangitaon ng area kay 3, which is the equation of 1 minus 0.05 will equate to 0.95. Kung ato dong gamiton og calculator, kung kani equate na to ni sa calculator dito, ang value din sa iya kay 1.806. Now, here's another example when you don't have a calculator using the t table. Now, suppose you have a random variable with v is equal to 6, which is the degree of freedom. Now, ginapangita daw ang t, ang area daw sa t nga dire. Nawa ka gitagaan og area ani, imong pangitaan yang area. Ang gihatag lang kay 2.447 with the degree of freedom is 6. Tanaw din nimo sa t table, 6 degree of freedom kay mo ni siya, imo ding alpha mo ni mong pangitaon dire. So, pangitaon na nimong 2447. Mo man yung 2447, then ang alpha din nimo kay mo din imong i-cart nimo, mo din imong alpha. So, ang imong area dire is 0.025. 0.025. Now, nato isa ka problem dire, which is the probability of t is less than or equal to 2.447. Now, gitaga na naman tayo value sa area above sa t, which is 0.025. Then kabalo man tayo in every PDF shape bell curve is mo equal gini siya og 1. So, ato lang ni siya minusan 1 minus 0.025, we will get the area of this under the t variable, which is 0.975, and that is the answers of using the t table without using the calculator. Given the sample mean and sample standard deviation of a random sample from a normal distribution with an unknown standard variance, we can see here that the t distribution has also two-sided confidence interval. Two-sided confidence interval and one-sided confidence interval, just like the z distribution. Now, reminder that L, big letter L and big letter U is a estimate value of lower and upper. And you can see that the equation of lower and upper estimation is similar to Z, except that instead of lambda we use S, and instead of Z we use T as the value of here.
Example, construct a two-sided 99% confidence interval on mu, the population exam 1 mean from a previous semester using the sample 1 scores 41, 47, 36, 33, 37, 37, 46, 26, and 36.
Now, using the two-sided CI from the previous slide, here is the example. Now, the given score are here and above. Now, to scale it to 100%, we just need to times to the current value that we have, which is resulted into this. Now, the given CI of this problem is 99%, which is in decimal point is 0.99. Now we can get the value of alpha, which is this. to get the value of alpha, you just need to manipulate this equation to become to make it to 1 ay alpha is equals to 1 minus 0.99, and the result is this. Now we get the result of alpha. We need to divide it to 2 to get the upper area of the two-sided confidence interval, now which is 0.005. Now we know that the number of sample is 10. We can count it, and we can solve the t value of the t distribution. We know that the a over 2 is 0.005, and the n minus 1, which is 10 minus 1, which equals to 9. Now we can solve the t variables using the current given values. Now we have the a over 2, which is the 0.005, and n minus 1, we can get that because we have already have the n minus it to 1, and we will get the degree of freedom, which is 9. Using the t table or the calculator, whichever you prefer, you will get the value of 3.248. 298 using the calculator or the t table. Now to get the x bar, you just need to sum up all the value of each value of here, divide it to 10, and you will get the 75.2. And the sample standard deviation, we discussed it before, that the equation of this sample standard deviation is this. Plug in all the variables that we given, and you will result it to 12.1546. Now we have all the variables that we need to solve the lower and the upper estimation bound. First, the lower estimation bound, which is x bar. We already have the x bar 7.75.2 minus the t, which is the 3.298 times s, which is 12.1546, divided by the square root of n, which is 10. Calculate it in the calculator, and you will result to 62.708. Now for the upper estimation bound, you just repeat the process, but instead you will add the one. Instead of negative, it is positive. 2, 5 plus 3.298 times 12.1546 divided by square root of 10, which will conclude the result into 82.69,691. Now that we solve the lower and the upper estimated bound, we can interpret this as the probability of the interval, the lower bound, which is this 62.708 from 82.691, contains the population mean mu, contains the population population mean, which is mu, contains the population mean, which is mu, is 0.99. And that is the final answer of solving the example without knowing the standard variance of the random sample.
Confidence intervals for the variance and standard deviation. So just like any other confidence interval, like for the mean and proportion, here in the standard deviation and the variance, we will still be using the point estimates or the point estimation. So it is presented here. The point estimate for the variance, denoted as the sigma squared, is the S and called the sample variance. And the point estimate for the standard deviation, denoted as the sigma, is just the S and called the sample standard deviation. So, in dealing with this certain topic, certain confidence interval, we will not be using the previous distributions like the normal distribution, T, Z, so on and so forth distribution, but rather instead, particularly, we will be having and going to use the chi-square distribution. So, this chi-square distribution or chi-square distribution is extremely different to the previous ones, and it's one of the biggest difference is when you graph this, it will look like this. So, imagine, mao siya, mao ni ang U gyapon siya, but it's something like defined as skewed to the right, ana. Compared to the other distribution, other distribution, it has a perfect symmetry nga murag siya bell, ana. Murag siya perfect ngayon and is perfectly balanced. Then, as expected, if inani ang format niya sa graph, nagit siya positive values and negative values. Here in the chi-square or the chi-square, iyang values lang is only positive. So, this property or the properties here explained will be more tackled and mas maklaro pa as we dig deeper to the topic. Mas matubag pa nato why inani ang graph, why inani ang graph sa other distribution and inani yaha, and how it depends and related to the degrees of freedom. So, to continue the topic, I will be having a recap about the relationship of the variance and standard deviation. So, basically, the standard deviation is just the square root of the variance, and the variance is just the square of the standard deviation. So, mangutana mo, like, gibalik-balik na siya, it's very obvious because it is very important and essential sa pag-compute na jud o pag-analyze a problem involving the confidence interval of variance and standard deviation. So here, we have the properties of the chi-square or chi-square distribution. Okay, mao tong ingon gaina in this certain topic, we will be dealing with the chi-square or chi-square distribution. So first, all values must be equal or greater than 0. So, dapat ang chi-square value or the chi-square value must be greater or equal to 0. Kaya ma-explain na siya tungod sa iyang graph. Kaya since this is the 0, mauni ang iyang graph. And as we've noticed, wala siya bound or curve diri dapita. That's why its value lang is 0 or greater than 0. And it also means that ang tanan niyang critical value is positive. The second property is the curve and the shape of the chi-square depends on the degrees of freedom. So basically, ang formula sa degrees of freedom is stated here. N minus 1, and the N is the statistical sample or the sample size. So kung may ng problem nga, ang iyang N is inani, so mauna atong N, minusan lang natong 1, aron mauna ang degrees of freedom. So, the third one is the total sample area is equal to 1. So basically, pretty obvious sa mga probability problems or probability functions, mo equal ginagawa ng iyang total nga curve since it is probability. So, second property or the second to the last, it is not symmetric. So mo tong ingon gay na. Dili siya symmetric, dili siya perfectly bell-shaped kang iyang bound yung graph skewed to the right. And lastly is each value is different of each degrees of freedom. So this one connected na sila halos. Like halos connected na sila. Like the reason of this one is this one. Kay mayon ta pag mo change ang iyang graph, like for every diri, mo change iyang degrees of freedom, magkalahi-lahi ang iyang critical nga value. So, these properties will not end here kay mo compute pa ta og mga problems involving this one. So, ato lang ning timan-an nga concept aron like mo follow ta sa chi-square distribution nga property. So, to continue the topic, we have here the critical value of the chi-square distribution. So, as you see, natay duha ka formula. This one is for the right tail and this one is for the left tail. So, basically, ang atong formula, this one, basahon ni siya as the chi-square of the right is equal to 1 minus c over 2. So, basically, ang c is the level of confidence kung may ang problem nga construct a chi-square table that is 99.9% confident ana. So mao na siya ang c, i-express lang nato into decimal. So naingon na po na nako in the previous. Second one is the chi-square to the left. Mao na siya ang formula 1 plus c over 2. So basically nag-differ lang siya sa operations na ninduha. So this one is the right side of the right tail and the right side of the left tail. So, short information about the chi-square or the chi-square distribution is that the columns are called the alpha and the rows are the degrees of freedom. So, if akong ingon gaina nga there is a somewhat like rectangular coordinate system nga pamaagi, so mao to siya ang column kay alpha and the rows are the degrees of freedom. So, ano dayon? If you're going to ask, mauna ba ni ang actual nga solving problem? So, dili pa. Gi-discuss lang ni siya because this is very essential sa pag-solve na sa actual problem kay balik part ang ni siya sa gipangayo, like part ang siya sa variable na need to provide ang value. So, we have here a sample problem involving the critical value of the chi-square or chi-square distribution. So, find the critical values for the chi-squared R and L for the 95% confidence interval with the sample size is 18. So, first thing first is to list down the given. So, in solving the critical values of the chi-squared, we need to have to find the following things. So, first is the degrees of freedom. Second, first is the n. Second is the degrees of freedom, and the third is the confidence interval in terms of decimal. So basically, kani nga mga quantity kay naara sa problem. So the n, it is shown here nga ang iyang sample size kay 18. So ang iyang n kay 18 ra sad. 18. So then the formula for the degrees of freedom is known to be and discussed earlier nga n minus 1. So, after ang buhaton, 18 minus 1 is equal to 17. And then the c, 95%. And we need to express this in terms of decimal. So, mag-append sa decimal. So, ayun mo siya, 0.95. So, basically, we all have, like, we got all the values needed to solve for the critical values. So now, isa-isa na to sila pagsuma ang right and left tail. So, the formula for the right is chi squared to the right is equal to 1 minus c over 2. So basically, 1 minus RC is the 0.95. So here 95 over 2. And for the left side is chi squared to the left is equal to 1 plus matik na nato 0.95 over 2. And the answer of this is 0.025, and the answer for this one is 0.975. So, mangutana mo, unsa ang pulos daning duha nga ang formula man kay mao ni ang ginagamit. So, this ano lang, like ibalik na to, we're going to validate the second property gaina nga what I have said nga ang total area is equal to 1. So if you're going to add this value and this value, 0.025 and 0.975, mo equal na siya og 1. So na-validate na nato ang second nga property. So now back to the question, unsa ang pulos na nila? So in the chi-square table, ang kaning atong nanga-solve is not yet the critical value. Mao pa lang niya atong ginatawag nga alpha. Muni sila ang mga alphas. Kani. So basically, the alphas are the columns in the chi-square table, and the degrees of freedom is the rows. So mao ni siya. I'm going to like present in the screen the chi-square table, and ang system sa pagpangita sa critical value is just like same ra siya sa murag rectangular coordinate system nga bali kaning degrees of freedom kay mao ni atong coordinates, and then ang kaning duha ka alpha mao pa ni atong another coordinates. So bali naatay 17 0.025 and 17 0.975. So these coordinates bali ato ni siyang pangitaon kung unsa ang iyang value paingon dito sa chi-square table. So let's say ato na nakita. So ano di ang pagpangita is like natay mo nito table ana mao ni dire ang degrees of freedom, and then these the degrees of freedom, and these are the alpha. So if dire atong 0.025 and then dire atong 17, so kung aha sila nagtabo mao na lang ang value. So kaning duha naa ni sila different value. So the first value for the kani, so nakuha na nato yung alpha. So the first value for the right is the critical value. So R is equal to 30.191, and the L is equal to 7.654. So mao bali ni, so these two are the critical values for the chi-square R and L for 95% confidence interval. So recap sa solution, ipakita na to una ang sample size na sa given, ang confidence interval, I mean the degrees of freedom nga gikan siya sa sample size kay minus sa nag-1 mga siyang 17. And then ang kaning C, which is the confidence interval, gi-express na nato into decimal. So mo ng 0.85. Computing the alphas, so kani chi-square to the right and chi-square to the left, we have arrived to this value. Ana, gihimo din na nato siya ang way aron malocate nato atong actual nga value dito sa table. Following this degrees of freedom, dito sa table gi-state dito nga there is degrees of freedom and then there is the alpha. So mo nang buhaton na to atong locate kung asa sila magtabo nga point, and then that is the value. And for the values, the critical values in this alpha, mao ni sila these two. And then why are we computing this? So this is not the actual problem solving sa confidence interval for the variance and standard deviation. Bale, essential lang ni siya. Like, pag abot dito sa formula sa actual na solving, part lang ni siya dito, and we need to get this in order to solve the actual problem. So since we're done getting the critical value of the chi-square R and L, we will now be moving up to the actual problem. So, before that, I will be explaining the formula in solving one. So, ano siya? Ako na yung specify. So, this formula is for the confidence interval in terms of the variance. So, the variance denoted as sigma squared will be having this condition of range. Ano siya? And in solving this problem, you're going to solve this independently in each side. So, in this left side, sumaho na nimo siya different dani and different dana. So, independent imo pagkasuma duha. So, the n here, the n, is just the sample size. This one is n. And then, the s squared is the point estimate, as what I've discussed, like the very first, mo siya ang point estimate for the variance, and the point estimate for the standard deviation is just the s. So, mo siya, point estimate. This denominator sa first is the chi-square r nga mao tong atong gikuha nga critical value gaina nga 30.191. So mao na siya atong i-fill in if like gikuha na to ang critical value. So here same goes here, dari and sample size, point estimate, and then dari same value sa left side nga critical value sa L, chi-squared L. And then second sa CI for standard deviation. So basically, as what I've explained ako kaina, like the recap about the relationship of the standard deviation and variance. So, kay variance man sigma squared. So to find the sigma, ato lang na siyang square root both sides since this is independent from left to right. So, mauragapon same quantities, point estimate, sample size, chi-squared R, chi-squared L. So, that's it. So, since we're done explaining the formula and finding the confidence interval of the variance and standard deviation, so we will be having a steps, like a summary of steps in solving an actual problem. So, aron masayon siya, naalang ta i-follow ng mga steps aron to solve for the CIs. So, first, i-assure na to nga ang problem is normally distributed ba, or the state ba niya nga the problem is follows a normal approximation or it is normally distributed. So, i-find na to if naa ba in order to solve using the chi-square distribution. Second, i-identify na to ang n and the degrees of freedom. So, n is the statistical sample or the sample size, and the degrees of freedom is just the n minus 1. Third is identify the point of estimates. So, katong point estimates, giingon ako pinakauna, like the first thing in sa video, the point estimates, it is the s squared or s. So, point estimate for the variance and point estimate for the standard deviation. So, the fourth one is to find the critical value of the chi-squared R and chi-squared L. So, mara itong ibuhat like in the first problem solving. Third ayon, gilocate na nato ang value. So, since we got here a degrees of freedom and the alpha, ilocate na to ang actual nga value dito na sa chi-square distribution table. So, let's say ato nang nakuha. And then, prior to this, gidiscuss na ko ang formula about finding the confidence interval. So, i-follow na rin to nato ang formula, supplying all these quantities following the formula aron makuha na itong confidence interval for the standard deviation and the variance. So, since we discussed already the formula, we extracted it, and we already then reiterate the steps in solving the problem. So now, we will be having the first example. So, the example presented in the screen, you randomly select and weigh 30 samples of an allergy medicine. The sample standard deviation is 1.20 milligram. Assuming the weights are normally distributed, construct a 99% confidence interval for the variance and standard deviation. So, sa katong gi-reiterate na ko nga steps, we're going to like validate first kung ang problem gapalo ba og normal distribution. So, it is stated in the third sentence nga assuming the weights are normally distributed. So, we already hit the first step. And the second is we're going to identify this quantity. So the n, the degrees of freedom, and the s squared. So ano sila? The n is the sample size or the statistical sample. The degrees of freedom, the df, can be found from n minus 1. And the s squared is the point estimate for the variance. So, in the problem, makita lang ni nato tanan nga problem ay nga quantities dito sa problem. So, since it is stated that there is a 30 sample, so atong n is equal na po sa 30. And then, expected, the formula for the degrees of freedom is n minus 1, so the df is equal to 29. The s squared, it is given in the problem nga niingon siya dito na the sample standard deviation is equal to 1.20 mg. Pero kato siya kay sample standard deviation raman to. And ang atong is squared is for the variance man, so ato to siya ni square. 1.20 mg square. Mao na ang atong s squared. And then, second is the C, which is 99%, equal na po na siya, 0.99. So, the first solving din atong buhaton is to find the chi-squared from the R to the L. So, the left and the right. So, following the formula, katong x squared R and x chi-squared L, katong 1 minus c over 2, 1 plus c over 2. So, supplying the values in the formula, 1 minus 0.99 over 2, and then 1 plus 0.99 over 2. So, I will be calculating this. So, 1 minus 0.99 over 2. So, we have 5 times 10 to the negative 3. And then for the left side, 0.995. And if we're going to use the degrees of freedom and these values, we'll be arriving to the value of the R and the L. So R and the L. Here we're going to use the chi-square and the chi-square distribution table. So ato sa table, katong dito doon ako how to locate the values, and then let's say na-locate na nato, we have the value of 52.336, and then for the L, this one is 13.121. So since we already arrived with the chi-square R and L, we will be now going to compute the actual confidence interval for the variance and standard deviation. So we're just going to erase this one. So we're going to write again the n is equal to 30, df is equal to 29, C is equal to 0.99, R is equal to 52.336, L is equal to 131.121, 13.121, and then S squared is equal to 1.20 mg squared. So the formula for finding the CI, as I would explain it before, is CI for the variance is the n minus 1 s squared over this of the R squared, and then the n minus 1, same here, and then it just differs on the denominator because it is in the left side. So supplying the values, 30 minus 1 times 1.20 squared over 52.336. So it goes here, 30 minus 1 times 1.20 squared over this value, 13.121. So we're going to compute this independently, like i-compute ni nato dire, compute pa rin na nato dire. Lahi siya pagka-compute kay it must be computed that way. So we have the value for the left side as we're going to calculate squared over 52.336. So it is 0.80 squared, and then a 3.118. Yes, 3.118. So this is the final answer for the CI of variance. So since the problem state that we still need to find for the standard deviation, so basically in finding that, we're just going to square root each value. So we're going to square this one and square this one, and we'll be arriving to 0.9 on 89 sigma 1.78. So this is the confidence interval for the standard deviation. So recap, first thing first is i-confirm na to, follow na tong reiterated na steps. Then we find the quantities here, the N, the DF, the C, the R, and the L sa chi-squared distribution table. And then i-follow na rin na to ang formula on saan pag-get sa variance or confidence interval for the variance and the standard deviation. So again, muna atong value for the CI of variance and then the CI of the standard deviation.
Last topic for today is the confidence interval on the population proportion. So basically, this is very proportional. It's not continuous, it is discrete. So basically, it's a normal approximation for the binomial proportion. So the whole basis for the set of equations is on the binomial distribution. The binomial distribution is when we're interested in a bunch of Bernoulli trials, and each Bernoulli trials has a probability of descriptive P of occurring. And so for a Bernoulli trial is that what it's showing here is that we have a success probability of descriptive P and the failure probability of 1 minus P. So this is here. As you can recall, we can create a standard normal random variable Z, which has a population mean of 0 and a population variance and a standard deviation equals to 1. And the way we can create a Z is by taking one random variable, which is x minus the mean over the standard deviation. So where does this formula come from? So now, if I recall, we also know that the expected value of x is the expected mean. So expected value of x is the mean. So the mean is equals to the n times p, and the variance is equals to np minus 1 minus p. So now, if you can recall, the formula for z in a normal distribution is z is equals to the random variable minus the mean over the standard deviation. So we're just going to substitute the values. So z is equals to x minus n times p over the square root of n times p times 1 times 1 minus P. So, there you have it. P is the estimated proportion of an observation in a random sample of our size n. So, this is just the same sa mga gipang discuss sa mga akong groupmates gay na. Ang difference lang is ako is proportional. So, dili ko nagamit og normal distribution. Nagamit ko og binomial distribution. So, basically, it is proportional. So, murag yes or no, ana na mga data, or how many people wear their seat belts, ana. So, high or low. So, ilaha numbers, ako is categorical or maybe binary. So, for two-sided confidence interval, so P is between L and the upper boundary. So, it is equals to 1 minus alpha. So, it is just the same. So, the lower boundary is equals to the sample proportion minus the subscript alpha over 2 times the standard error, which equals to the square root of P hat times 1 minus P hat over N. So, the upper boundary is just P hat plus Z subscript alpha over 2 times the standard error. So, and then the sample proportion is equals to X over N. So, for one-sided proportion, so we're just going to remove the other side. So, basically, if the lower side is just we want to find the lower side, so L is equals to P hat minus Z subscript alpha. So, we are not going to divide it by 2. So, times the standard error, and in the upper boundary is U hat is equals to P hat plus Z subscript A times the square root of P hat times 1 minus P hat over N, or the standard error. So, that's basically it. So, in a random sample of 85 automobile engine crankshafts bearings, 10 have a surface that's rougher than the specifications allow. Construct a 95% two-sided confidence interval for P. So basically, we're going to write P is the population parameter is between the lower bound and the upper bound. So P is the probability of the bearing not meeting the specifications. So what we are going to write, first the given. So X is equals to 10. Our sample is 85. And then our alpha, since we want to construct a 95% confidence interval, so our alpha is 0.5. And since it is a two-sided, we are going to divide our alpha by 2. So alpha over divide nato sa 2 is equal to 0.025. And then our z subscript alpha over 2 is equals to z subscript 0.025. So, basically, sa mga previous problems, isolve naman natin siya. So, it is equals to 1.96. So, basically, then ang P na yun, ang proportion par sample nato is P is equals to X over N. So, basically, proportion sample is equals to 10 over 85. So, basically, we have all the information. Now, we are just going to plug it in our formula. So, the L is equals to our proportion sample minus Z over alpha over 2 over the standard error, which is equals to P minus 1 over P over N. So, substitute that. So, we have 10 over 85 minus 1.96 square root 10 over 85 minus 1 minus 10 over 85 square over 85. So, that is equal to 0.0492. So, we have our lower bound. So, solving for the upper bound, we have U hat is equals to 10 over 85 plus 1.96 over 10.85 times 1 minus 10 over 85 over 85. So, our upper bound is 0.1861. So, now, our the probability that the interval is the probability that the interval of the CI is a 95% is between 0.0492 and 0.1861. What if somebody came up and said, how big should my sample size be? So my estimate of this proportion is within the true population proportion by a certain amount. So basically, kung ang sample size na daw ang atong pangitaon, so given ang atong error, ang atong probability, so sayo na rin siya. So ano siya is the standard error, i-derive ra nato ni para balhin na nato ng n diri sa e. So basically ang buhaton ta kay ano siya, squared ta ni siya, e is equals to d alpha over 2 squared. So ano din siya, mawala na rin siya. So p hat minus p 1 over plus p hat over n. So are baylo na din siya. So na din tayo n is equals to z alpha over 2 over e squared times p 1 times p times 1 minus p. So basically, this formula came from here. The sample size from this equation will always be a maximum for p is equals to 0.50 or 1/2. So how do we know this? So take the first derivative with respect to p and set it equal to 0. So then solve for p. So basically, what we are going to do to find our maximum, iba, naalala nyo itong sa derivatives ta kay pag find tag minima ug maxima, i-derive na nato. So ano siya? Derive ra ni nato siya with respect to p. So basically, ano siya? dp ito siya, z alpha with standard error squared, and then p minus p squared. Since constant ni siya, pwede siyang pagawas. So ayan, mabuhat ani z alpha over standard error squared. So, bilin ra, more atong i-differentiate. P minus P squared. So, ari, simple. Constant. Z is equals to alpha over 2 over E times 1 over 2 P. So, ano tayo? Since to find the maxima, we're going to set it equals to 0. So, solving for p, we have, ano siya, makancel naman siya. Right? Divide din mo siya both sides by a constant, times, divide sa constant, 0, 1. So, mabili na 1 minus 2p equals to 0. So, p is equals to 1/2. Or equals to 0.5. That's all. P is equals to 1/2. So what we're going to do next is we're going to substitute 1/2 to P. So ano siya? May mo siya 1/2 times 1 minus 1/2. So basically 1 minus 1/2 is 1/2. So 1/2 times 1/2 is 1/4. So 1/4 is equals to 0.25. So sa maximum niya, natay formula na n is equals to z alpha over 2 over e squared times 0.25. Nata, mo ni ang iyang maximum. Continuing our previous problem, how large a sample is required if we want to be 95% confident that the error is using blank to estimate t is less than 0.04. So basically, ang ginapangitaan ni Dre is ang sample size. So, sa formula sa sample size is N is equals to Z over subscript alpha over 2 over error squared, quantity squared, times P times quantity 1 minus P. So basically, substitute na to atong tanang values. So natay 1.96 over 0.04 squared. So times na to sa atong P. So which is 10 over 85 times 1 minus 10 over 85 is equals to 75 over 85. Then, lagyan natin sa atong calculator, equals siya og 249.2. So, round up na to siya, mayroon siya 250. So, if you wanted to at least be 95% confident that our estimate proportion P was within 0.04 regardless of the value P we use. So, ang gamito nato ani is tong formula na gi-derive nato o itong maximum siya, itong formula na i-derive nato kag i-set nato 0 which is the maximum. So, ato siya is N over Z alpha squared over standard error quantity squared times 1/4. So, plug in nato siya. So, yung siya 1.96 over 0.04 squared times 0.25 which is equals to 600.3 plus i-round up pa natin siya, ngayon siya 601 bearings. That is all. Thank you. Recap. So, if we are given a population mean or we want to find what is the population mean, we are going to use this formula. So, ano siya? The confidence interval is x bar plus minus the t subscript alpha times the margin of error. Margin of error if there is less than 30 samples. So basically, kung gamay ang imong samples, ang gamito nimo dili ka mobase sa normal distribution. Mobase ka sa t-distribution. So, I will not talk kung asa manigikan, kung sa magiging siya giderive. So, basically, naano siya table. Kung sa statistics na to, kung mas gamay ra ang imong samples, 30 or less than samples, is, ano siya ang ganito na to. Pag mudako na ang atong samples is greater than 30, basically, at the t-distribution will become a normal distribution. Kung mudako ta, kung mo greater siya, basically, may mo siya normal distribution. So, mo na ang normal distribution na ito ang gina-calculate. So, pwede ni siya. Pero, masayo ni siya i-calculate. Okay. Mas simple na siya. So, mo na ni. Now, kung ang atong population proportion, mo na ang atong formula na gamiton. So, basically, ang mga data ani is binary or categorical. So, basically, yung mga nag-affect sa width ng ating mga confidence interval is ma-proof dito. So, basically, kung taas ang imong variation, kung taas ang imong standard deviation, basically, ang confidence interval natin is mag-widen siya. So, basically, hindi siya mas accurate kasi mas maraming intervals, iba-iba. So, basically naman, kung mas malaki ang N natin, mas maraming sample size, mas accurate ang data natin. Let's say, yung kanina, 1,000 ang ating population. So, kung para gusto natin maging accurate talaga, ano ba, 99.9. 99 na lang. 99. So, di ba, para, kung ganito karaming apple at ganito karaming apple, parang pareha na lang ang mean nila. So, isa lang ang nagkukulang. So, kung i-calculate mo tong mean nito, by common sense, malapit lang. Warang indistinguishable na lang. Hindi na natin malaman kung ibaba. Yan. So, that's all for today. Thank you for watching and please subscribe to our YouTube channel so that we can help more students learn statistics. Goodbye.